you've all tightened your shoes up because your socks are about to be knocked off. I've got them all night. That's your punishment for taking too long to listen. Rubbish puns. So, our final speaker of the evening is Peter, or Pete, from Iotec.
Make sure it's almost... Is the microphone? No.
Switch it all the way.
Any better? Oh, that's, yeah, that's it. So, let's go and that picture. Okay, much better. Okay, so first of all, I'd like to just introduce myself. My name is Pete Silverwood. I'm the Chief Scientific Officer at Iotec. We're a local company. We're shortly going to be moving up to the Plymouth Science Park, and we are building an intent marketing platform, which for today, what I'd like you to hear is that we're doing big data analytics and machine learning, and we work in the digital advertising sector. Now, we think digital advertising is a really natural home for big data technology. And I'm just going to show you a slide to tell you why. When you use your device, be it a tablet or a desktop device, and see display advertising, those ad opportunities are being traded in quite a sophisticated data marketplace. And to give you an idea about the scale of what's happening there, in the UK alone, we're looking at around 20 billion ad opportunities being traded automatically every day. And in terms of sizing that data, that's about 9 terabytes of data. Every single one of those opportunities has to be processed within 20 milliseconds. Quite a quick SLA. And just give an idea about that, since I've got the slide up, that's going to be around 15 million ad opportunities since the slide went up. But of course, we're not talking about just the UK. This is a global industry, and this is happening 24/7 around the globe. So we're talking about some serious volumes of data. But what I want to talk tonight is about what I do and how we're looking at extracting as much information as we possibly can from this data, and ultimately that's about improving the performance that we deliver for our end customers. But really what I'd like to talk about this evening is what I've dubbed the data science nexus. The 3 parts that I'm going to talk through, and it's around how these different parts come together around the data to really work. We'll start with people. We've got to talk about the maths of it, and then we'll talk about the technology and how that all works. So let's kick off with people and data analytics. We're all really familiar with accessing data using things like pie charts and heat maps, bar charts and so on. These are all really easy ways for us to process and understand about the data that's in the system. It's readily accessible through a system. But there are a couple of weaknesses to the way that people work with data. And what I'm going to ask to illustrate the first of my points is I'm going to need a little bit of help from the audience. So what I'd like to do first of all is just show me that you're voting on work, please. Yep, excellent, thank you. All of them work, it's great. I'm going to show you a sentence, and what I'd like to do is count the number of F's that you see when you read this sentence. Okay, have a go in that time. So, first of all, did anybody get 0, 1, or 2? Couple of arms, good. When I did this, I got 3. Did anybody else get 3? Yeah, good number of arms. Anybody get 4? 5 or 6? Yeah, good selection. The normal response to this question is that people will normally get 3 to 4. And the reason for it is that when we are reading and trying to extract this data, we tend to focus in on the grammatical words and the noun. We're focusing on the noun and the verb words. So we see finished, files, and scientific. We will tend to skip over the grammatical words of. So quite often these are mixed. And it's just an example of one of the filters that people will apply when they're trying to interpret or understand data. Add on top of that a couple of biases that we always bring. Negativity bias, we will tend to look at negative effects in the data and find them much more important than perhaps they really are. And confirmation bias, we tend to look at the patterns that we want to see. So quite often when people work directly with data, you can often come away with misleading conclusions. For the second point, I'd also like to talk about complexity. Visualization is really a key tool for us to actually be able to understand and interpret the data. At a very simple level, 2 dimensions, we can clearly see that there's a pattern in the scatter plot on the left. And even and then we can look at 3 dimensions, where we can see the grouping of the data. And again, we've got this huge capacity for recognizing these patterns. But even when we're looking at plotting in 3 dimensions, we're starting to run into difficulties with the media. So this is clearly a 2D screen, and we're trying to project those 3 dimensions onto it. So it will depend on how we orientate it, whether we can actually see the groupings. Then think about it in 4 dimensions. How on earth do you start exploring that? We could start reaching for VR headsets, or we could be looking at animations. But we have to work hard to interpret the data when we talk about that level of complexity. And just to give you an idea, when we look at the data we're processing, I think we need a solution which works 42, much higher dimensionality. So clearly visualization is not the answer. We'll turn to another technique, and this is the core of what machine learning is. And it's about modeling the data that we've got and finding relationships between the data. So this plot, we all can see the relationship, and the challenge is to try to relate x, a kind of prediction variable, to y, what we want to know about, and find the formula for the red line. We can all do that as people. The trick is, by doing it with maths, we can extend that out to deal with that much higher dimensionality data that we're trying to work with. And that means, I'm afraid I do have to talk about the maths for a little while. And I promise there is no crowd interaction for this particular section. One of the main tasks in any machine learning is classification. So again, this is very much the same kind of problem, that we've got different data points, and in this case we've got two different prediction variables where it is on the screen. And the task here is to work out, are the dots blue, are they orange, or are they red? And if we've got a good model, we can shade in the background. And the wonder of this, of course, is that if we get a new data point in, perhaps falls here, we can make a prediction, say actually yes, that's going to be a red dot, or in the top left corner, it's a blue dot. It helps us to, once we've got that model, we can make predictions about what's going to come next. And of course, I do have to show you a bit of maths, so I promise I'll keep it light, and we did try to kind of jazz it up a little bit. Yeah, it was tough, I've got to tell you that. But there is an important point here. This formula brings together x, which is what we're trying to predict, or the prediction variables, y, what we're trying to work out, and then we've also introduced some variables, w0, w1, which are the parameters. And it's going to lead me on to the question which I'd really like to think about, which is how do we learn from the data? And the best way, I think, is just to rephrase a little bit. How to repeatedly update our model parameters so that it most closely represents our data. And this is fundamentally what we're trying to do when we're doing machine learning. And what we want to do is find small iterative updates and algorithms that we can apply to make sure that our weights fit the data that we're seeing. And that update might look like this. Big chat here. When we're doing training, these updates are applied tens of millions of times potentially. And if I can bring you back to slide 2, I was talking about 20 billion ad opportunities. We're also having to make predictions with this model, serious volume of time to do it during a day. So to make this work, we do need to rely on the third party like data network, and that's tech. And we are dealing with some really seriously big data. So inevitably, when we're talking about tech, I've got to show you a picture of tech stack. We use a number of contemporary data handling technologies. We work entirely in the cloud. We're using Amazon Web Services for all of our server infrastructure, using Django and PostgreSQL for the UI side of things. Big data batch processing is supported by technologies such as Hadoop and Spark. And then up when we talk about really fast, really quick data, we have to look at technologies such as Cassandra and Redis, which are just called NoSQL databases. But really, the message I'd like to leave you with on technology is small things really matter when you're trying to scale up. You can't get away with an inefficient program. And here's just an example. We wanted a model. We're running a model, a simulation using a technique called markov-chain multi-Carlo. And the basis of that is you compute probabilities tens of millions of times to actually understand uncertainty within the data. This is a recursive algorithm, mathematically quite correct and it's easily implemented. But when we're looking at how well that performs, it actually gets exponentially worse performing as you'll notice as n increases. So we had to go, when we actually tried to put this into production, this sort of timed out and it caused all sorts of problems. We had to go back to the drawing board and look at a much more efficient algorithm based on putting together a sort of n-squared matrix, and this actually allows us to run through. So the algorithm mattered, and it really made a difference when we tried to scale up the performance of that data. But at the end of the day, what does this all mean? And what I'm talking about here in terms of the discipline of building a learning system, handling this data, it's part of what we're trying to build at Iotec. We're also looking at data integrations, at user interfaces, and the supporting infrastructure which allows us to talk about a global platform. And we've got some, we've really sort of honed the way which we deliver campaigns using desktop. We're now also really looking into the mobile market. We've had some really strong growth in 2016. We're looking at rolling out globally, and more than anything else, just want to say that we're trying to build a top-class big data machine learning capability here in Plymouth. So I think that's for me something really exciting as somebody from this area. We'd like to leave you with the last thought though. We talked a lot about machine learning and artificial intelligence, and there's been a lot of coverage in the media in the last couple of years around what artificial intelligence, what impact that might have in terms of the jobs and society. I'd just like to ask a question and leave it open to think about. Do you think machine learning and artificial intelligence is a threat and is going to destroy our jobs? Or is it actually something which is a huge opportunity for us to explore new industries, new opportunities that actually wouldn't have existed without this technology? That's my food for thought. I hope you'll have a think about it. I'd like to just say thank you. On any other topic than that last question, because it could go on for a long time. I'd welcome any questions.